So in this video, we're going to be finding a point on a line that is closest to another point. And anytime you hear the word closest, you want to think minimum distance. That's what we're going to be using for our optimization, the minimum distance. And so our distance formula is d squared equals, and then it's the difference in the x's squared plus the difference in the y's squared. This is our a squared plus b squared equals c squared. There are other videos that will explain the distance formula for you, but that's what we are using. So we have some line and some point, which looks like this. So here's our point, here's our line, and on this line there are an infinite number of points. And what we're trying to do is find the point that has the closest distance. So if I pick this point, you can see there is a distance here. I pick this point and there is a distance here. So what we want to do is find the closest distance for a given point. So if we take that picture that we just had there, we draw our line and we draw our point, what we can do is label this point on here x, comma, y. And then now we can plug those in and that will give us our distance that we're looking for. So d squared equals, and then this would be x, take away, I'm putting them in color for you, 3 squared plus, and then y, take away 0. And just like before, we want everything to be in terms of one variable, right? So we want our d in terms of just x or y. Well, up here it says y is equal to 2x plus 3. So we do have a secondary equation that we can use to plug it in. So this would become x minus 3 squared plus, and then now we can plug it in, 2x plus 3 minus, and then minus 0 is nothing. So there we go, we got squared. Now, taking the square root would allow us to do this explicitly, but we're going to do it implicitly because it's a little bit less complicated. So this would be 2d, d prime, because remember it's not an x, we're taking this with respect to x. And then this would become 2x minus 3 to the power of 1, we're using chain rule, times the derivative of the inside, plus 3, 2x plus 3 to the power of 1, derivative of the inside, chain rule. And then if we multiply this out, we get 2x minus 6 plus, that's a 2, so I got ahead of myself there. That would be 4 times 2, which is 8, and then 4 times 3, which is 12. So we have 10x plus 6 equals 2d, d prime. And then now we can just solve it, and this would be 10x plus 6 over 2d. Well, d is just the square root of that. So this is 10x plus 6 over the 2 square root of x2 minus x1 squared plus y2 minus y1 squared. So you can see all that really mattered was this anyways. This right here was all that really mattered anyways, because that's what's going to give us 0. So if we set the top equal to 0, we get 10x plus 6 equals 0. So x equals negative 0.6. I know I solved that quickly, but now we know our x coordinate. So if we were to draw that line again and put 3, 0 on here, we know that perpendicularly, so if you know these rules, that the distance that's closest is always the perpendicular, because any other distance you can see is farther away. So it's always the perpendicular that's going to give us the closest. But we now know that that point has an x-coordinate of negative 0.6. Now we just need the y-coordinate. So if you look back at our y equals 2x plus 3, and we plug in negative 0.6, we get 1.8. And that is our y-coordinate. Now I've already got the Desmos set up so that we can check this. Since I knew it's perpendicular, if I click on the perpendicular line, it gives me my intersection point, and there it is. Negative 0.6, 1.8 would be the closest point to this point on the y equals 2x plus 3 line. And that's how you find the closest distance.